Welcome back to Molecular Machines for Dummies. After the PDC, acetyl-CoA is fed into something called the Krebs cycle. This cycle is continuous and produces NADH, FADH2, as well as some ATP.
So in this video, we are going to focus on how your body finally creates all the ATP it needs to function. This process is primarily done with an enzyme called ATP synthase. This enzyme is a part of a larger chain of complexes in the mitochondria called the electron transfer chain, or ETC. This chain contains 4 complexes along with ATP synthase, which is also referred to as complex 5. Complexes 1, 3, and 4 are able to remove electrons from the NADH and FADH2, which are previously produced in cellular respiration. These complexes pump protons into the inner membrane space of the mitochondria, as electrons are transferred throughout the ETC. The electrons in all of the complexes are eventually transferred to oxygen, the final electron acceptor, to make water at complex 4. Finally, it's time for ATP synthase to do its job.
ATP synthase is made up of 2 primary components, F1 and F0. F1 is outside of the mitochondrial membrane in the mitochondrial matrix and is where ATP is made. F0 is embedded in the inner mitochondrial membrane and moves protons from the inner membrane space into the mitochondrial matrix.
F0 and F1 are made of various subunits. F0's primary subunit is referred to as the C ring. This is the part of F0 which pumps the protons across the membrane through rotating in a counterclockwise manner. F1 has 3 catalytic sites that do not rotate and is connected to F0 by a gamma subunit. When the C ring rotates, it also moves the gamma subunit of F1. This causes the different catalytic sites of F1 to change in conformation to produce ATP.
ATP synthase is vital to human life, as it is the primary source of ATP in your body, and as we know, ATP is necessary for your body to function. Unfortunately, there are several mutations in your body that can impact ATP synthase in a person's health. Many mutations have been found involving the gene which is responsible for creating a subunit of F0. These mutations make it impossible for F0 to rotate and pump the protons, therefore ATP synthase loses its functionality. These mutations are known to lead to neuromuscular diseases such as NARP and maternally inherited Leigh syndrome. Sadly, there are no current cures for this mutation. However, some recent studies have shown promising results in administering molecules that aid in enhancing ATP production in previous steps of cellular respiration.